So previous lecture আমি simple harmonic motion start করেছিলাম. What is the equation of simple harmonic motion? The equation of simple harmonic motion is d2x dt2. So this equal to minus mu x, right? So this is the equation of simple harmonic motion, right? And what is the general solution of this equation? The general solution of this equation will be x is equal to a cos root mu t plus epsilon. Okay. What is the velocity? What is the velocity? That is v square is equal to mu into a square minus x square. What is a? A is called the amplitude, right? We know the definition. What is amplitude? Basically, amplitude is the maximum distance from the center of oscillation. From the center, okay? The maximum distance from the center is called the amplitude, okay? And what is periodic time? Periodic time of simple harmonic motion, that is t will be t is equal to 2 pi by root mu, okay? So these are the very, very important result. So the velocity, that is v square is equal to mu into a square minus x square, where a is the amplitude. What is the equation of simple harmonic motion? The equation of simple harmonic motion is d2x dt2 is equal to minus mu x, okay? Right? Maximum acceleration, that is mu a, okay? So last we solve this problem, right? So first of all, please correction this. এই প্রবলেমটা দেখো, এই প্রবলেমটা আমাকে কি কি বের করতে বলেছে? ফার্স্ট অফ অল, we have to show this is a simple harmonic motion. We prove that this is a simple harmonic motion because this is of the form d2x dt2 is equal to minus mu x. Up to this clear? And what is the time period? The period is 2 pi by root mu. Here mu is 2. It's okay. But amplitude, how to find amplitude? Amplitude of the motion is the maximum value of x on the either side of the center of oscillation. That is, what is the amplitude? Basically, amplitude is the maximum value from the center of oscillation, either this side or this. Origin থেকে, this is the center, এদিকে অথবা left side, maximum the distance, that is the amplitude, okay? The maximum distance from the center is called amplitude, ঠিক? But এই প্রবলেমে দেখো, আমার previous যে প্রবলেমগুলো ডিসকাস করি, দেখো for this problem the equation of simple harmonic motion, দেখো d2x d2 is equal to minus mu x, mu is 1, দেখো ডিরেক্টলি আমি পেয়ে গেছি, ওকে? ডিরেক্টলি আমি ফর্মটা পেয়ে গেছি, ঠিক? That is, here center is at x is equal to 0, origin সেন্টারটা, ঠিক আছে? But for this problem দেখো আমরা কিন্তু ডিরেক্টলি পাইনি, তাই না? আমরা এখানে ট্রান্সফরমেশন ইউজ করেছি। উই ইউজ দিস ট্রান্সফরমেশন। দেখো d2x dt2 which is not is of the form d2x dt2 is equal to minus mu x, আমি কি করেছি 1 plus mu x কে z পুট করেছি। দিস ইজ দ্য ট্রান্সফরমেশন, রাইট? তার মানে কি সেন্টারটা অরিজিনে নেই, গেটিং মাই পয়েন্ট? তাহলে সেন্টারটা কোন পয়েন্টে আছে? দেখো z is equal to 0 পুট করো, that is x is equal to minus 1 by 2, x is equal to minus 1 by 2 পয়েন্টে সেন্টার, গেটিং মাই পয়েন্ট? আমি প্রিভিয়াস যে প্রবলেমটা ডিসকাস করেছিলাম, জাস্ট সি দিস প্রবলেম, এই প্রবলেমে দেখো ডিরেক্টলি আমি সিম্পল হারমোনিক মোশনের ইকুয়েশন পেয়ে গেছি, ওকে? বাট ফর দিস প্রবলেম, দ্যাট ইজ দিস প্রবলেম, ডিরেক্টলি কিন্তু আমি সিম্পল হারমোনিক মোশনের ইকুয়েশন পাইনি, ঠিক আছে? এখানে আমরা কি করেছি, ট্রান্সফরমেশন ইউজ করেছি, 1 প্লাস 2x কে z পুট করেছি, ঠিক? ওকে, 1 প্লাস x কে আমি কি পুট করেছি, z পুট করেছি, ওকে? ক্লিয়ার? তাহলে সেন্টারটা কোন পয়েন্টে? z ইজ ইকুয়াল টু, যদি তুমি 0 পুট করো, দেখো সেন্টারটা হচ্ছে x ইজ ইকুয়াল টু মাইনাস 1 বাই 2 পয়েন্টে। Clear? Okay. Clear? So basically for the simple harmonic motion with center of force at the origin is d2x dt2 is equal to minus mu x, okay? d2x dt2 is equal to minus mu x, that means here the center of force is at the origin. ওকে, ঠিক আছে, ক্লিয়ার? ওকে ওকে, সো দেখো এখানে আমি d2x d2 is equal to minus mu x, mu is 1, ঠিক? তাহলে সো center of force is at the origin, but for this problem the center is not at the origin. Getting my point? What is the center? Center is basically z is equal to 0, put karo x is equal to minus 1 by 2 the center. The center is at 1 plus 2x is equal to 0, that means x is equal to minus 1 by 2. ঠিক আছে? ওকে, ক্লিয়ার? সো প্লিজ কারেকশন দিস, ওকে, প্লিজ কারেকশন দিস। ওকে, সো হিয়ার দেখো আমি এই প্রবলেমে x এর দুটো ভ্যালু পাচ্ছি, x is equal to minus 3 or x is equal to 2, ঠিক? So here the turning points are basically x is equal to minus 3 or and x is equal to minus 3, x is equal to minus 3 and x is equal to minus 2, ঠিক আছে? তাহলে মিন পজিশনটা কি হচ্ছে, দুটো মিন পজিশন দ্যাট ইজ অ্যাভারেজ minus 3 plus 2 divided by 2, that means minus 1 by 2. দেখো আমি তাই পেয়েছি, x is equal to z is equal to 0 পুট করো, that is x is equal to minus 1 by 2. That means সেন্টারটা কোন পয়েন্টে? সেন্টারটা হচ্ছে minus 1 by 2 পয়েন্টে, ঠিক আছে? ওকে, ক্লিয়ার? ওকে, তাহলে আমি সেন্টারটা যদি অরিজিনে হতো তাহলে ডিরেক্টলি আমি বলে দিতে পারতাম, দেখো প্রিভিয়াস যে প্রবলেমটা ছিল সেন্টারটা হচ্ছে অরিজিনে, তাহলে x এর যে ভ্যালু দ্যাট ইজ x is equal to 4, this is the amplitude, ঠিক? Because center is at the origin, but for this problem the center is at x is equal to minus 1 by 2. তাহলে যে ডিস্টেন্স যেটা পেয়েছো সেখান থেকে সাবট্রাক্ট করো, মানে 2 এর সঙ্গে 2 minus 1 by 2, ওকে? That means what do we get? 2 minus, that means 2 plus 1 by 2, so 4 plus 1, that means 5 by 2, right? So 5 by 2 means 2.5, ঠিক আছে? ক্লিয়ার? Again x is equal to, যখন when at a distance x is equal to minus 3, that is minus 3 minus 1 by, সেন্টারটা কোন পয়েন্টে? minus 1 by 2, so minus 3 minus 1 by 2, okay? So this will be minus 3 plus 1 by 2, that means minus 6 plus 1, that is minus 5 by 2, that is 5 by 2, so that is 2.5. দেখো দুটোর ক্ষেত্রে সেম, that means the amplitude will be 2.5. clear? okay, for this problem the center is at x is equal to minus 1 by 2, সেন্টারটা কোন পয়েন্টে? minus 1 by 2 পয়েন্টে। তাহলে আমি যে ডিসপ্লেসমেন্টগুলো পাচ্ছি x এর ভ্যালু জাস্ট সেখান থেকে সাবটা 2 minus 1 by 2 and minus 3 minus 1 by 2, so we get the same values, that is the amplitude is given by 2.5. okay, so right here the turning points are the turning points are x is equal to 2 centimeter and x is equal to minus 3 centimeter. And what is the mean position? Therefore just mean means average, therefore mean position so this will be 2 minus 3, that is just add করে to the divide average, okay? So 2 minus 3 divided by 2, that is minus 1 by 2. You can also find the mean position, that is center. Mean position here for this mean position means center of oscillation for the motion, okay? So z is equal to 0, just if you put z is equal to 0, that is x is equal to minus 1 by 2, so here the center is at x is equal to minus 1 by 2, Clear? What is the amplitude? Amplitude is the distance from the center. That means distance from the mean position. Clear? Okay. The amplitude is the distance, the amplitude, suppose we denote this is A. The amplitude is the distance from the origin, distance from the mean position, distance from the mean position, distance from the mean position to either turning point, to other side, to either side, or you can say either turning point. Okay, so here when x is equal to 2, so distance to x is equal to 2, so distance to x is equal to 2. For this case, the amplitude, suppose A1, so this equal to modulus of 2 minus mean position is minus 1 by 2, so 2 minus 1 by 2, that means, so this equal to 2 plus 1 by 2, 4 plus 1, that means 5 by 2, that means 2.5 centimeter. Getting my point? And for this second, when distance is x is equal to minus 3, okay, so distance to x is equal to minus 3, so amplitude, that is A2 for that case, so 3 minus 1 by 2, so that means 3 plus 1 by 2, so 3 minus 3 here, okay, minus 3, so A2 is minus 3 minus 1 by 2, so this equal to minus 3 plus 1 by 2, so that means minus 6 plus 1, that is minus 5 by 2, so modulus of minus 5 by 2, that is 5 by 2, so this will be 2.5 centimeter. Okay, so see this, so we get the same distance, so both the distance are equal. So what is the amplitude? The amplitude will be 2.5 centimeter. Okay, clear? Since both distance are equal, since both distance are equal, the amplitude of the motion is the amplitude of the motion is A is equal to 2.5 centimeter. Okay, so this is the answer. Okay, so what is the amplitude? The amplitude will be 2.5 centimeter. So this is a simple harmonic motion. What is the time period? Time period is 2 pi by root 2. And what is the amplitude? Amplitude is 2.5 centimeter. Okay, clear? Next problem. Note this problem. First of all, note this problem. For a particle executing simple harmonic motion, proof with usual notations that f square t square plus 4 pi square v square is equal to constant. What is f? F is the acceleration. What is t? T is the periodic time. What is v? V is the velocity, right? What is, so what is the equation of simple harmonic motion? That is d2x dt2, right? What is the equation of simple harmonic motion? d2x dt2. So this equal to minus mu x. So basically this is the acceleration, right? So f is equal to minus mu x. Getting my point? What is mu? So mu is the constant of proportionality of acceleration and displacement, right? Right? What is mu? We know that is f varies minus x. X varies x, right? We take negative sign because the force is towards directed to the origin. So that's why we take negative sign. Okay. So note this. We know that. So f is equal to minus mu x. So we know that answer for a simple harmonic motion, answer. We know for a simple harmonic motion, we know for a simple harmonic motion, if x be the displacement at any instant, if x be the displacement at any instant means time, okay? And what is mu? Mu be the constant of proportionality of distance and displacement. Mu be the constant of proportionality okay, of acceleration and displacement, okay? And what is a? A is the amplitude, and a be the amplitude, and a, so this be the, and a be the amplitude, then what do we get? F is equal to, what is the equation of simple harmonic motion? d2x dt2 is equal to minus mu x. So this is the acceleration, that is f is equal to minus mu x, right? So f is equal to minus mu x, okay? What is velocity? That is v square is equal to mu into a square minus x square. What is time period? T is equal to 2 pi by root mu. We know this result. Suppose this is equation 1, this is equation 2, and this is equation 3. This is equation 1, this is equation 2, and this is equation 3. Okay, so we know this. Now from this t is equal to 2 pi by root mu, right? So what is mu? So this implies that, so from 3 we get, from 3 t square is equal to 4 pi square. T square is equal to 4 pi square by mu, right? Okay, so this implies, what is mu? From this, mu will be 4 pi square by t square, right? So this implies that mu is equal to 4 pi square by t square. Okay, so this is mu, right? Okay, now from velocity expression, from 2 we get, from 2 v square is equal to, v square is equal to mu a square minus mu x square. So this equal to mu a square minus, from equation 1, what is x? X is f by minus mu, right? So mu into x, x is minus f by mu. Okay, so from equation 1, so ultimately what we get? Mu a square minus mu f square by mu a square. So that is mu a square minus f square by mu. Mu cancel, right? So I think up to this, no doubts. Okay, okay. So from this equation, suppose this is equation 4. Suppose this is equation 4. What is mu? Mu is 4 pi square by t square. So 1 by mu, that is t square by 4 pi square. So this equal to mu a square minus f square into 1 by mu, that is t square by 4 pi square. Left hand side is v square. So v square is equal to this. Now multiplying both sides by 4 pi square. So this implies that 4 pi square v square is equal to 4 pi square mu a square minus f square t square. ठीक? Okay, clear? So this implies that 4, so this implies that f square t square, this implies that f square t square plus 4 pi square v square. So this equal to 4 pi square mu a square. Okay, obviously amplitude a, so this is constant, mu is constant, pi, so this is constant, so ultimately this is constant. Okay, since a and mu are constant for a simple harmonic motion, so this implies that, f square t square plus 4 pi square v square is equal to constant. Okay, since a and mu are constants for simple harmonic motion. So we proved that, f square t square plus 4 pi square v square is equal to constant. So it is a very, very important result. We proved that f square t square plus 4 pi square v square is equal to constant. Okay. So let us consider next problem. Note this problem. Note this problem first. Okay. So the speed v, that is velocity, the speed v of a particle moving along the x-axis is given by v square is equal to 64 into 8 mx minus x square minus 12 m square. So that the motion is simple harmonic with center at x is equal to 4m. So we have to find the center. Okay, so just a problem to this problem and this problem is similar type problem. Okay, for this problem, what is the center? What is the center? Just you put z is equal to 0, that is x is equal to minus 1 by 2. So the center of the simple harmonic motion will be minus 1 by 2. Okay, ঠিক আছে, same problem, same type. Okay, the speed v of a particle moving along the axis of x is given by v square is equal to 64 into 8 mx minus x square minus 12 m square, so that the motion is a simple harmonic. That is, we have to prove this is of the form, that is d2x dt2, so this equal to minus mu x. If we get this is of the form d2x dt2 is equal to minus mu x, then we conclude that the motion is a simple harmonic. Okay, and what is the periodic time? The periodic time, that is t, will be 2 pi by root mu. Getting my point? T is equal to 2 pi by root mu. Okay, so we have to show the center is at x is equal to 4m. That দেখবে এরপর ট্রান্সফরমেশন দরকার হবে. Okay, and what is the period of oscillation? The period of oscillation is pi by 4. Okay, so note this problem. The speed v of a particle moving along the axis of x is given by v square is equal to 64 into 8 mx minus x square minus 12 m square, so that the motion is simple harmonic with center at x is equal to 4m, and that the period of oscillation is pi by 4. Okay, so what is given? Here we have the velocity expression. We have v square is equal to 64 into 8 mx minus x square minus x square minus 12 m square. Okay, right? So now differentiating both sides with respect to x, right? So differentiating with respect to x, differentiating with respect to x, we get 2v dv dx. So this equal to 64 into 8m minus 2x, right? Okay, now dividing both sides by 2, so what we get? So this implies that v dv dx, so this equal to, that is 64 into 4m minus x, just dividing both sides by 2. V dv dx, that means d2x dt2, right? We know that acceleration, that is d2x dt2. Also this can be written as v dv dx, right? So v dv dx, that means d2x dt2. So this implies that d2x dt2, so this equal, taking minus sign common, that is 64 into x minus 4m, right? Okay, so what we get? d2x dt2, so this equal to minus 64 into x minus 4m. Okay, what is our target? We have to show the differential equation is of the form d2x dt is equal to minus mu x. ठीक? So now just you put x is equal to minus 4m, x minus 4m is equal to z. Okay, so put x, x minus 4m is equal to z, right? So put x minus 4m, so this equal to the same type problem, okay? 1 plus 2x, that is z, okay? Same type, getting my point? Okay, so this implies that, dx dt, so that is dz dt, right? So again differentiation, that is d2x dt2, so this equal to d2z dt2, okay? So d2x dt2, so this equal to d2z dt2, right? So I think up to this clear, no doubts. Suppose this is equation 1. Suppose this is equation 1. Okay, so suppose this is equation 1 and this is equation 2. Okay, suppose this is equation 1 and this is equation 2. So from 2 we get, from 2 we get d2x dt2, so that is d2z dt2, d2z dt2, so this equal to minus 64 x minus 4m, that is z. So ultimately we see that d2z dt2 is equal to minus 64z, that means which is of the form d2x dt2 is equal to minus mu x. Hence the motion of the particle is simple harmonic. What is the center of the motion? The center of the motion is given by z is equal to 0, that means x is equal to 4m. What is the time period? What is mu? Here mu is 64. What is mu? Mu is 64. Mu is 64. Time period, that is t, is 2 pi by root mu, right? So 2 pi by root mu, mu is 64, right? So that means 2 pi by 8, right? That means pi by 4. Clear? Okay. So which is of the form, which is of the form d2x dt2, so this equal to minus mu x. Hence the motion of the particle is simple harmonic. Hence the motion of the particle, is simple harmonic. Hence the motion of the particle is simple harmonic. What is the center? Whose center is given by, whose center is given by, just you put z is equal to 0. Z is equal to 0. That is x minus 4m, that is x minus 4m is equal to 0, right? So or x is equal to 4m. So what is the center? The center is at 4m. Okay. And what is the period of oscillation? The period of oscillation and the period of oscillation and the period of oscillation that is 2 pi by root mu, and the period of oscillation is 2 pi by root mu. Mu is 64, right? 2 pi by 64. That means 2 pi by 8. That means pi by 4. Clear? So we proved that. The motion. So we proved that the motion is simple harmonic. Okay, and whose center is at x is equal to 4m, and the period of oscillation is pi by 4. Okay. So next example. Note this problem. A particle executing simple harmonic motion in a straight line has velocities v1, v2, v3 respectively. Okay, at distance x1, x2, x3 from the center of path. Okay, so basically here it is given that v1, v2, v3 are the velocity distance from the origin, that is distance from the center of force. What are the distance? x1, x2, x3. We have to prove that x1 square into v2 square minus v3 square plus x2 square into v3 square minus v1 square plus x3 square into v1 square minus v2 square is equal to 0. Okay, so note this problem. A particle executing simple harmonic motion in a straight line has velocities v1, v2, v3 respectively at a distance x1, x2, x3 from the center of the path. We have to prove that x1 square into v2 square minus v3 square plus x2 square into v3 square minus v1 square plus x3 square into v1 square minus v2 square is equal to 0. So what is the velocity expression for simple harmonic motion? We know that v square is equal to mu into a square minus x square, where a is the amplitude and what is v? V is the velocity at any distance x from the origin. Okay, the equation of simple harmonic motion is d2x dt2. So this equal to minus mu x. What is the velocity expression? That is velocity v square is equal to mu into a square minus x square. Right? Clear? Where v is the velocity at any distance x from the origin. Okay. So answer, we know that v square is equal to, we know that v square is equal to mu into a square minus x square. Okay, where v is the velocity at any distance, where v is the velocity at any distance x from the origin. Okay, so here the velocities are given by v1, v2, v3 at a distance x1, x2, x3. Okay, so therefore v1 square, so this equal to mu into a square minus x1 square. Thick. Okay, clear? v2 square, that is mu into a square minus x2 square. v3 square, that is mu into a square minus x3 square. ठीक? Clear? So v1 square, so that is mu into a square minus x1 square, v2 square, so that is mu into a square minus x2 square, v3 square, that is mu into a square minus x3 square. Okay, so that means mu, so this equal to mu a square minus mu x1 square. So this equal to mu a square minus mu x2 square. So this equal to mu a square minus mu x3 square. Okay, okay. We have to prove that x1 square into v2 square minus v3 square plus x2 square into v3 minus v1 square plus x3 square v1 square minus v2 square. Now we are going to calculate v2 square minus v3 square. So therefore v2 square minus v3 square. So this equal to v2 square minus v3 square. This minus this. So mu a square cancel, that is minus mu x2 square plus mu x3 square. ठीक, this minus this, so mu x3 square minus mu x2 square. ठीक, okay. Next, v3 square minus v1 square, v3 square minus v1 square, v3 square, this minus this. Okay, this minus, so mu1 square cancel, that is minus mu x3 square plus mu1 square. So mu x1 square minus mu x3 square, right? Okay, v1 square minus v2 square, v1 square minus v2 square. So this minus this, so ultimately what we get, mu square cancel, so minus mu x1 square plus mu x2 square. So mu x2 square minus mu x1 square. ঠিক আছে? Okay, now left hand side, here the left hand side, so that is x1 square v2 square minus v3 square plus x2 square into v3 square minus v1 square plus x3 square into v1 square minus v2 square. So this equal to x1 square v2 square minus v3 square. So this is mu x3 square minus mu x2 square plus x2 square v3 square minus v1 square. So mu x1 square minus mu x3 square, right? Plus x3 square v1 square minus v2 square, that is mu x2 square minus mu x1 square. Clear? Now just simplify this. If you multiply this, so what do we get? That is mu x1 square x3 square minus mu x1 square x2 square plus mu x1 square x2 square minus mu x2 square x3 square plus mu x2 square x3 square minus mu x1 square x3 square. Just simply multiplication. Okay, clear? I think up to this no doubts. So mu x1 square x3 square minus mu x1 square x3 square cancel, right? Okay, minus mu x1 square x2 square plus mu x1 square x2 square cancel, right? Okay, plus mu x2 square x3 square, okay, minus mu x2 square x3 square cancel. So ultimately what we get? So this equal to 0. Okay, so we proved that x1 square into v2 square minus v3 square plus x2 square into v3 square minus v1 square plus x3 square into v1 square minus v2 square. So this equal to 0. Okay, so it is very important, the velocity expression for the simple harmonic motion is v square is equal to mu into a square minus x square. What is a? Where is the amplitude, right? And what is x? X is the distance from the origin. Okay, the equation of simple harmonic motion is d2x dt2 is equal to minus mu x. Okay, the velocity, that is v square, is equal to mu into a square minus x square, where is the amplitude, and x is the distance from the origin. Okay, so I think all points are clear. So thank you so much. Bye.